Hello everyone, welcome to this webinar about BIM Energy, a software where you can calculate the energy efficiency potential in your house. We are going to go through the workflow in BIM Energy today. I hope this webinar fits for both new users or if you want a recap of the software. The software is used by real estate companies or energy experts, and it's used for making energy audits or calculations of energy efficiency actions, or map the energy usage you have in a building. Today it's me, Linnea, and Christine, who is going to guide you through this webinar. And we are working with BIM Energy on sales and support. This is the workflow in BIM Energy. First, you choose a climate file. Where is your building situated? Next step is to create the building geometry. After that, decide the constructions, either selecting from a catalog or defining them yourself. Next step will be the building internal loads and the activity in the building. You also describe the ventilation and the heating and cooling systems. And after that, you describe if you have a solar panel in the building. These are the input parameters to make the energy calculation. When that is done, you can study the results. And from the results, next step is to see if you are interested in making an energy efficiency action, to try different alternatives and then compare them to see which energy saving is the most efficient and taking decisions from that. All right. If there are any questions during the webinar, you can write in the questions to your right. It should be in the chat. And we're gonna answer them in the end of the lecture. Okay, Christine.
Hi, yes, now I'm Christine. I'm also joining you right now. Okay, so I will talk a little bit about StruSoft first before we go on to BIM Energy. So StruSoft, we are a software provider for the construction industry. And we have our energy calculation software, BIM Energy and VIP Energy. And we also have softwares regarding structural analysis and precast design planning, for example. And here you see a few of them. We have film design, impact, pre-stress, for example. StruSoft we started within Skanska for about 35 years ago in the 80s. And our head office, it's in Malmö in Sweden, but we also have offices in, for example, Denmark, Hungary, Finland, Romania, and India. So we are a provider of our software, and we both develop, support, and have sales offices. So now if we focus on BIM Energy again, as you will see when we move to the application, it's a comprehensive and easy to use energy calculation software. And the calculation performs, it calculates hour by hour during the year, and it's fully dynamic. And as you will see, it provides fast answers to complex questions regarding energy efficiency in the real estate sector. And if you want to read more about BIM Energy, you can either contact us after the webinar or visit our website, bimenergy.com. Here are some examples of energy efficiency actions that can easily be simulated in BIM Energy. So we start with creating the energy model of the existing building as it looks today. And then we create different alternatives with the different actions that we want to try to see the energy savings from the alternatives. So for example, we can add additional roof insulation. We can try to see if we change all the windows to windows with better U value to see what the energy saving that will lead to. We can also model with an heat pump. We will see we have a catalog with predefined heat pumps that you can use in your calculation, and we have heat pump types of both exhaust air, geothermal, air to water, and air to air heat pumps. Of course, we can also simulate the air handling units to see the ventilation flows and how that change the schedules to see how that affects the building. And we can also use the calculation to calculate not the measured entities to see to use that for energy audits, for example. And when you want to see how much energy can you save by different renovation measures. And to try a few of these measures, we will see later on when we go to the application. And before we start modeling in BIM Energy, we will just talk a little bit about dynamic energy calculation. And so when we create an energy model of our building, the program looks at it sets up the energy balance of the building, and it looks at both the emitted energy from the building and the supplied energy. So we need to have the same amount of emitted and supplied energy to have the energy balance of the building. When we have the model of the building, we also need to choose a climate file so that we get the solar irradiation, wind velocity, outdoor temperature, and humidity to get the full calculation. When we define the climate barrier, we can see how much energy is emitted from the building with the transmission. We define the heating and cooling set points and define the activity in the building. We need to give information about the technical installations, other heat pumps, the air handling units, cooling machines, and so on. And in the dynamic hourly energy calculation, the program takes into consideration the thermal inertia of the building and also the air leakage from the building parts. So yeah, let us have a look at BIM Energy, and we will guide you through the workflow. I will share my screen for you. Yes. Okay, so to access BIM Energy, first you need to create an account at our portal, which is where I'm now. And so after I have created an account, I have my license in the account. I click Go to App on BIM Energy, and I will be redirected. So now we will go through the workflow, and if you have any questions, just write them in the chat and we will answer them afterwards. Okay, so here we see the workflow of BIM Energy, and we go from left to right, and we start by creating our project and define the climate file, select the climate file to our building. And after that, we create the geometry of the building. So we have the climate barrier. We go through and insert the activity in the building. We add the ventilation, the heating, the cooling step, and then we can add solar panels and then look at the result in the report step. And as we do our changes to the calculation, we will see how the calculation will calculate momentarily, and we can see how the changes, how that updates the result. So we see the emitted and supplied energy here to the right, and we also see the heat supply and the electricity. So yeah, we start by defining our project. Create a new project. Give it a project name. And now we also need to select the climate file. And here you can choose from the map here to get a climate file from any location around the world. And today I put my calculation in southern of Finland, in around Helsinki. And a climate file is downloaded from the American Climate Institute, NOAA. And apart from selecting my climate file, I also select a catalog to my project. And here we have a default catalog provided by us in BIM Energy. So I default the default catalog and create my project. It's also possible to create your own catalog and with predefined constructions and so on. And we will have a deeper look into the content of the catalog later on in the workflow, but it contains constructions, materials, and so on that we want to use in the climate barrier. Okay, so I start by creating my first building, and now we want to model the building as it looks today. Then we create alternatives of the building with the different renovation measures that we want to try out. So I give it a project name, Building Today. And now when I create my first building, we see that the application already starts to calculate, and it starts to calculate on this building. We look into the basic geometry here. So you define the geometry of the building by inserting the width and the depth of the building. So for example, I can insert 20 times 25 meters. I add the number of stories. For example, now I want to calculate an apartment building with 5 stories. So this is a very easy way of creating the geometry and get started with your calculation. We can also change the story height here. Okay, so apart from this basic geometry, I also click here that I want to use airtight floors in my building, and it affects the thermal pressure around the building. And if you have another geometry of your building, and if it's not rectangular, as I have measured this building, we can continue to the next step when we go in and edit floor plan. And here we can edit each story individually. So if I, for example, have we might have an entrance here on one of the facades. So I go in and edit the floor plan on my first story. I can change the snap interval here. So for example, if I create some new points here to define the building, another geometry of the building. Now, of course, we need to have a look at the drawings of the building to see how we can model that. I save my changes. So now I change the geometry of the first floor, but I can also copy if I have the same geometry of all the building, all the stories. So now I created another geometry of the building that I'm satisfied with. If we go into the edit glazing part, we can see that we have windows has already been generated on the building, and the default data is 20% glazing for all of the facades here. We can switch if you want to insert the glazing in square meters instead, if we have that measured from the building. And so here, for example, I change some of the glazing here. That's something that I think represents the glazing on my building. And the application starts to calculate on this new in data instead. What we also can do is that I can use the functionality to share my building, and that means that I can share my building with another colleague, for example. So now I will share this building with Linnea, for example, if we want to calculate on the same building, and I give her right permissions and share my building with her. And that means that she can make the changes to the same building, and I will see the same changes in this building now when I have shared it with her. Okay, so that was the geometry of the building. The next step is to move on to the construction. And here we will have a deeper look into the catalog that we selected to our project. So the catalog contains information about different typologies, constructions, materials, windows, and so on. So it's a set of predefined items that you can use in your building. If we start with the typologies, we have 8 different typologies in the default catalog, and they vary from heavy or light building and varying insulation from poorly insulated up to super insulated. So when you're working with existing buildings, you might not have fully documentation about what material and what the thicknesses do we have in the building. So the typologies are, if we click to one of the typologies, we can see that a typology is a set of predefined combined constructions. So for example, in this typology, highly insulated light building, we see that we have an exterior wall here with the U value 0.2. We have a pre-selected roof with the U value 0.16 and so on. So the typologies are, they are there to help you if you don't have the fully documentation about what constructions are in the building. So that is something that you can start to work from. If you know exactly what materials and constructions you have in your building, you can of course create your own typology and combine the constructions that you have in your building, or you can use the predefined typologies if you know approximately if the building is heavy or light and what insulation you have. So I select here highly insulated heavy building. That is a good representation of the building that I want to model. And we can also see up here in the indicators, I have an average U value is calculated to 0.35 for this building. So that was the typologies. We can also see here in the constructions, for example, if I look at the highly insulated heavy building exterior wall, we see that that construction contains of these materials, facade brick, mineral wool, and so on, with the U value of 0.25. Of course, we can edit our own constructions, insert them and use in the typologies. We can go in and edit here, make the changes that we want, add materials, for example, and use them in our typologies. But we use this typology, highly insulated heavy building, to start with. Okay, so the next step is the usage, and here we need to give information about what activity do we have in this building. And here we give in data about the heating and cooling set points. And for example, we can look at the heating set point that's set for this activity template detached house. We see that we have inserted 21 degrees as the heating set point. Heating and cooling set points, we also have information about the domestic hot water need, the human heat gain, some building operational energy and occupancy energy, and information about the humidity. And here we have different usage templates. We have one for detached house, apartment house, and office. So now we are modeling an apartment house. So I start from this usage template. We can have a look. What heating set points do we have? It's also set to 21 degrees every hour during the year. If you want a varying schedule for the heating set points, we can go in and edit this schedule. So for example, if we are calculating a school, for example, when they have they might have one temperature in daytime and another heating set point in the nighttime, for example. In that case, I can start by creating the schedule myself to insert that from Monday to Friday, for example, between 7 to 6 in the evening. We want to have the heating set point to 21 degrees. And then during nighttime and in the evenings, we can have 22 instead. So that's one way of editing the schedule and adapt it to the building that you want to calculate on, for example. But now we are doing an housing building, where we want to use the same set point for the entire day. So I change it back to 21. So editing these schedules you can do individually for each in data parameter. And for example, the domestic hot water need, today we have it set to 2.85, I think. 2.85, but if I want to change that, if they have a lower or higher domestic hot water need, we make a change to that, and that will be the in data to our calculation instead. So the usage, either you can start from the templates that are already in the calculation, or you can create it on your own if you have another activity in your building. Okay, so from now on, Linnea will tell you a little bit more about the ventilation step.
Okay. Yes, let's move on to the ventilation step. I will only share my screen first. All right. So the ventilation step, here we describe the ventilation system. We create the ventilation system, call it something, and choose if it's exhaust air ventilation, exhaust and supply air ventilation, or exhaust and supply air ventilation with heat exchanger, or if it's just natural ventilation. Let's say this time we have exhaust air ventilation. We create it. Here we can edit the settings about the ventilation. If it would have been a supply air ventilation, we can decide how are we regulating the temperature on the supply air. For example, do we regulate the lowest, do we heat the supply air, or do we have a cooling system on the supply air? But we only have exhaust air ventilation this time. Yes. All right. Heat exchanger, so on. And then I can give the airflow of the supply air and the exhaust air. We can have a look at. So this is for the supply air. It's 0 since we don't have that one. And the exhaust air is on 0.35. But I can always change that. It's the same way as in the usage step. We can set a schedule for the airflow. But let's keep it 0.35 this time. And the fan settings, we set here the pressure of the fan and the efficiency of the fan. Okay. And now I would like to add an outdoor air intake because otherwise it will be a lot of internal air pressure. You can see, I think to your right in the picture, I choose this indicator, internal air pressure average. And if I unclick, it's gonna be a lot higher than if I have an outdoor air intake. You can see how it changes. The heating step is the next one. Here it's also interesting to follow the heat supply and the electricity use when I add different heating systems. For example, if I have a district heating or if I have a heat pump. I will show you how to describe a heat pump in this building. I can choose which kind of heat pump it is, air to air, air to water, and so on. This time we have a geothermal heat pump, let's say, a rock. There is a catalog of different heat pumps that you can choose between, but if you have another heat pump in your project, it's easy to describe that heat pump yourself and the inputs and the data about the heat pump. So I choose a heat pump in this list. That is a geothermal one. I add it. I can have a look at the settings about this heat pump. This settings is mainly from the supplier, that you can see the lowest temperature, highest temperature. This heat pump have a possibility to activate the control of speed and power, so that you can control down to 41% at minimum, but you can deactivate it. But let's keep it activated. You can see the heating output in watts, and it's connected to the water heating system, and it also heats the hot tap water. Yeah, I can regulate it like this. All right. I can have, if I have more heat pumps, I just add them to the list here. And here I will present the other data about how do I regulate the heat pump. Do I have an accumulator tank? And how big is that? The supply temperature and the drain temperature of my heating system. I can, right here, maybe I have a higher temperature in this building. I put it here, and that when I do a change here, I can always see what happens with the results. Always follow up. So that's the heating step. Next step is the cooling step. So since this is a residential house, it's very common that they don't have they don't have cooling machine or district cooling. So I will choose just passive cooling. But the cooling machine, it's a little bit like the heating step you describe. The input and district cooling we can describe. All right. You might have noticed that there is, even though I have passive cooling, there is a cooling in the emitted energy chart. This is because in the usage step, we have a cooling set point that is described like 27 degrees, and that's why the temperature over that is going to be cooled, but we don't cool it by a cooling machine or so on. Solar panels. We will come back to this step. Let's say we don't have solar panels in this building, but we can, yeah, we'll come back to and see how would that look if we would have had solar panels. Now we have put in all the data about the building and the installations. Let's have a look at the report. Okay, so Christine, Would you like to take this step?
I will only share my screen with you in a moment. Okay. So now we have gone through all the steps for defining our building. So we have the geometry of the building. We know what constructions we have. We have given information about the usage, ventilation. We have added the heat pump. And yeah, we have seen in the right here how the result has been updated when we have making the changes. And in the report step, all information about the in data and the report is gathered in one report. So if we scroll down here, we see information about the building that we have inserted, and then we have the result in the end with the energy balance, some key values, and the specification of energy supply, which is the amount of kilowatt hours with the supplied energy that we have in this building. And then now some information about the climate file. So this report, it's possible to print or have it saved at your computer. It's also possible to define which sections you want in the report. So if you don't want that much information about, for example, the surroundings or the material properties and so on, you can exclude them from the report to adapt it to the report that you want to have. What we also can do here in the report step, we can add, create our own graphs and add it to the report. For example, if we want to have a look at the heat supply from the heat pump and look at what is the highest energy demand for the building, we can define our own graphs and add them to the report. Okay, so now we have given all the information about the building as it looks today. We have had a look at the report that we can print out, and we know where to find the energy for this building. And as we see here to the right, we can see that the heat supply from the heat pump versus the heat supply that cannot be delivered from the heat pump. And we also see the electricity use that we got from the heat pump, for example. So now when we want to try some renovation measures, for example, if we want to add solar panel to this building and see how that how much energy we can save from that. What we do then is that we go back to the building step again. I click and create an alternative. So for example, now, because when I have added a solar panel to this building, I still want to compare the electricity supply of the building today with the energy with solar panels. So I create an alternative of the building to compare it with the building today. So by creating an alternative, I basically copy the information in the building so that I can start to make the changes. And now if we want to add solar panel to this building, we go to the solar panel step, create the panel. And here we also have one default PV cell in the default catalog, so I use that one. If I have information about a specific solar panel that I want to use in my calculation, I can of course insert information about that as well in my calculation. And the properties for this PV cell we can see in here. For example, we have the efficiency of the PV cell is 18% of this default cell. And we also have some information about so that the program can calculate what will the efficiency be with other temperatures and with other intensities, because this efficiency measures from the STC when we have high solar irradiation. So some coefficients that is used in the calculation, and some other parameters for the PV cell. And here you go in and edit if you have another solar panel that you want to use. But we use the default settings right now. If we go in and edit the solar panel here, we can also, because we need to give information about the area of the solar panel. So I try with the 40 square meters, and we have some tilt on the, because we place them on the roof, so I give it some tilt. So here you measure the solar panel. What's the size of it and how it is positioned. We can also go in and edit here the settings for the zone for this solar panel. For example, if we have battery capacity in the solar panel, and if we want to export the solar electricity to the grid if it's not used in the building, we can try that and see if we get some export to the grid. So how much solar electricity that we can use in the building, we can also see here down to the right, but we can also have a look at it in the report here to see. Because now also the solar electricity is included in the energy balance. We have utilized photovoltaic power here, so that the electricity demand to the heat pump, the bought electricity will be decreased. So we see here how the solar electricity is used, and it's used for the electricity supply to the heat pump and to the fan, the ventilation fan, and some occupancy energy. Okay, so now we can have a look here to the right to see the different value of the electricity. But if you want to have both of these buildings, the building today and the building with the alternative, if we want to have them compared, compare them between each other, we can go to this compare step. So this is a way of comparing the result of the different buildings and to look at them one by one. What we want to compare is the building today to the building with the solar panels. And here we can see the energy savings of both the heat supply and the electricity supply. And since we didn't make any changes to the climate barrier, we still have the same heat supply, but we can see that we have got an electricity energy saving since we used the solar, since we installed the solar panels, and used that electricity instead of buying electricity. So this is one way of we created an alternative of our building. We can see the energy saving from this action, and after that we can of course continue to make other changes. For example, if you want to know what will the energy saving be if we change the windows of this building. We can actually see that if we go to the construction step and have a look at the windows that we use in this building. We see that we use windows with the U value 1.7, which is a little bit high as well. So what we can do then is to, if we go in and edit our typology, instead of using these triple glazed windows, we can use the triple glazed with argon, which I know is a little bit higher U value. I save that one. I will see. Yeah, the U value of these windows are 1.1 instead, so they are better U value. And now I made these changes to the building when we already had the solar panels. So now when we go to the compare step, we will see how much energy we can save by both installing the solar panels and changing the windows. So now we also got an energy saving in the heat supply. And here you can add as many actions as you want, and you can create as many alternatives to have a look at the renovation actions separately, because now we see the energy saving of both when we install both the solar panels and make the renovation of the windows. So this is basically the workflow of the application. We create the energy model of the default building, and then we create alternatives with our actions, the renovation measures that we want to have a look at. We can compare the energy supply to the building and print out the reports from the different alternatives. So what we also can see here in the application, because if you're using the application and you have some questions about the workflow or a specific feature, for example, you can either contact us in the support team by submitting a ticket or calling us. And we also have a manual that you can, the way you can read further about the functionality to have a deeper look at it. So now we are reaching the last minutes of the webinar, and let's check with Linnea. Did we get any questions that we can answer from the attendees?
Yes, we have a question here about this other program, BIM Energy. Like, is this program a development of BIM Energy, and can I replace it? Joel wonders.
Yes. So we use the same calculation core to both BIM Energy and BIM Energy. And as you see, we have another user interface here to BIM Energy, and it's web-based instead. So right now, BIM Energy is adapted for calculating for existing buildings, to calculate the energy efficiency measures and the energy savings that you can get from the different alternatives. So we still recommend to use BIM Energy for new buildings, and BIM Energy is instead focused on existing buildings at the moment. But we are working on developing BIM Energy to get in more functionality so that BIM Energy also can be used for new buildings. But that's the difference between the programs at the moment. So that depends on what kind of projects do you do and if you can replace it or not. But yeah, we can stay in contact afterwards and answer your specific case further afterwards and send you an email to keep this contact, this discussion.
Yeah, that's interesting because I can add something to that. The BIM Energy program is used in many cases by to make like energy saving decisions on existing buildings. You can very easily see the results and present them in a very nice way. And this way to go through the steps, you easily grasp what how everything affects the result. So in that case, BIM Energy is very efficient and suitable for energy savings and so on, and energy audits. Many of the users of BIM Energy uses it for energy audits and energy savings. Yeah. We have another question. How much does it cost, the program, the software?
Yes, so when you have an account for BIM Energy, since it's web-based, it's a monthly fee. So you sign up for a contract of 12 months, and the price is 160 euros per month per user. So you use it, the fee covers the months that you want to use it, and so it's 160 euros per month per user. And in that price, the support and questions around the application is included in that price. What I can also show you a little bit is because Linnea before talked a little bit about the uses that we have, and here at the website we can see some examples of customers of companies that that use BIM Energy today. And so, in common for all of them is that they work with energy efficiency in different ways. We have energy consultants, energy companies who performs energy auditing, and we also have real estate companies, for example, StruSoft AB and HSB, for example. Municipality, Skövde municipality also use it to further look at the building in the municipality. So now after this webinar, we will be in contact with you, and we will offer you a 2 weeks free trial. So now when you are familiar with the workflow in BIM Energy, then it's suitable for yourself to try and the model, try some buildings and get even more familiar with the workflow. So it's 2 weeks free trial, and we will send you information about that right now after the webinar. And you will get our contact details afterwards in the email, and you can also always contact our support or send us some if you have any questions around BIM Energy. Okay, so thank you for attending this webinar, and now you are into the workflow of it, and we hope that we will be in contact with you again in the trial that you will start afterwards. Okay, so thanks for joining us today, and we will send you an email just afterwards. Okay, see you. Bye.